Hey, TechKnowSurge! Cryptography is not a new subject. In fact, we've been using cryptography for thousands of years. It's just with all this global access and all this connectivity, the need for cryptography has grown tremendously. There's a whole industry behind this, and it's a very critical part to cybersecurity. So in this video, let's go over some key concepts and ideas when it comes to cryptography. In this video, we're just going to hit some highlights of cryptography, cryptographers, plain text, ciphertext, encryption, decryption, cipher, what an algorithm is, cryptanalysis, keys, transposition, substitution, and steganography. So what does this word cryptography mean? Well, it's Greek, and it's made up of two components. The crypto, which means conceal, hidden, or secret, or graphy, which means drawing, writing, representing, recording, describing, or we can think of it as the art of. So you can think of cryptography as the art of concealing. Now, when it comes to cybersecurity, we can think of it as the art of concealing information. The example that we're going to use throughout this video is that we are going to hide the word secret or conceal the word secret. So we're concealing it into some sort of code like this. So what's the term cryptographers mean? Well, that's just the person who's going to be making or breaking these coded messages. Plain text is just the message that you have before you actually are going to convert it into a hidden message. Whereas ciphertext is just what we have after it's been converted. Encryption is what we call the process that happens when we take plain text and turn it into a ciphertext. Decryption is when we take the ciphertext and convert it back to the plain text. A cipher is just the process or algorithm that we use to either encrypt a message or decrypt a message. And so it is the process that it goes through to do this. And there's lots of different ciphers out there. It's a type of algorithm. Algorithm is just a generic term, but when it comes to cryptography algorithms, we call those ciphers. And depending on which cipher you choose, this output here, this encrypted format, the ciphertext is going to look quite a bit different. So if a cipher is a type of algorithm, what's an algorithm? Well, it's some sort of process that happens. You have some sort of problem or some sort of computation that you need solved. So there's some sort of output for this. And then you have some sort of input into it. So there's an input, it goes through this process, and then there's an output, and that's an algorithm. So an example here is that our algorithm or our cipher right here has a set of instructions. This is the process that we go through. So we start with the first letter. Our first letter is S, and we look it up on the chart. So we look up S on the chart, and then we substitute the letter with the new letter, which is V. So then we put the V right up here. And next, we're going to repeat steps 2 and 3 for the next letter. So we're going to take E, which is going to be H, and so we're going to put H there, and so on and so forth. And so that's the cipher that it's going through to convert this plain text into some sort of ciphertext. This particular cipher is known as the Caesar cipher because it was used by Julius Caesar around 58 BC. So this is a very old and very simplistic way that you could encrypt and decrypt messages. Cryptanalysis is the art of reverse engineering or decrypting things without knowing all of the variables that go into it. So in an example here, we have our ciphertext right here, being able to reverse engineer to find out what our plain text is without knowing all the details of how to decrypt this. And one thing that they look for is repeated letters. And so one of the most common letters in the English alphabet is the letter E. So if they see a repeated pattern here, they might try, first of all, saying, well, if H was an E, let's replace that with an E, and they could reverse engineer to figure out what the key is to reverse engineer this. And this particular one, the letters are shifted by 3. So you'll notice that an A is now a D, a B is now an E, a C is now an F, and all those letters have just shifted by 3 places. And so a cryptanalysis would be able to figure this out pretty quickly. So there are ways that we can make this a little more complex so that way it'll be harder to break. For instance, maybe this time when I send you a message, I sent it to you with shifting the alphabet by 3. But maybe next time it's going to be by 6. And maybe the time after that it's going to be by 9. I'm going to shift it a different amount every time I send you a message. Somehow you're going to need to know how many letters you need to shift the alphabet in order to decrypt this message. Well, that's where a key comes in. A key is additional information that you need in order to encode or decode a secret message. So in this case right here, the secret key is 8. So we shift our alphabet by 8 characters, and now when I encode this message or encrypt this message, an S becomes an A E becomes an M, and then when you reverse engineer this, or when you decrypt it, an M becomes an E, and A becomes an S, and you can decrypt that message. What we're doing here is a type of cryptography called substitution, where we're substituting in one letter for another letter. And although substitution is one of the most popular, it's not the only way that we can encrypt a message. Transposition is another way that we can encrypt a message. And so we do that by shifting the letters. Rather than substituting, we shift the letters around. Steganography is another way that we can hide a message. We're concealing it in something else. An example is maybe I'm concealing this word secret inside a picture, or I've actually concealed the word secret into this little sentence right here. So it's different than cryptography. Cryptography, we're actually converting. So secret gets converted into something that is supposedly undecipherable, or we need the key to be able to decrypt that message. Versus steganography is hiding it into something else. So you can actually pause the video here. I'm going to give you a chance to pause the video and see if you can point out what the pattern is that spells out secret, that this word is inside this sentence right here, but it's hidden inside there. So go ahead and pause the video, see if you can figure out what the pattern is, and then play the video to find out what the answer is. All right, and the answer is the word secret is spelled out by taking the first letter of every second word. So if you take the first letter of every second word, then we can see that it spells out secret. But as mentioned, we could actually hide it into other things, like this picture could have an embedded message that's hidden inside of it. As we move along through this module, we're going to be covering a lot of cool information, and we're going to be using these terms as we go. So make sure you have a good understanding of what these terms are, and we'll be using it throughout this module.